Hi everyone. The next topic is F random variable and F distribution. So remember that T distribution has one parameter, that is degrees of freedom. And depending on the parameter, the shape of the T distribution is different. And F distribution have the two parameters. One is so-called numerator degrees of freedom or degrees of freedom 1. And the other is denominator degrees of freedom or degrees of freedom 2. And F distribution is F random variable is defined by chi-square random variable with dfm divided by m divided by chi-square distribution with dfn divided by n. So this is the ratio of two chi-square distribution. And chi-square distribution usually represents some variance. So that means the F statistic, F random variable, calculates the ratio of two variances. So typically, if we have some statistical model and we have one variance sigma 1 square, another variance sigma 1 2 square, then we think about estimate of this. Then we think about the ratio. So F statistic, F random variable is used to see what's the distribution of sigma 1 hat square over sigma 2 hat square. So this is particularly useful when we compare the two linear model. For example, think about the y is equal to beta naught plus beta 1x plus beta 2x square plus epsilon. And another model is beta naught plus beta 1x plus some parameter zeta. And okay, so the first model have more variable, more predictor. So we expect that the size of variance epsilon is smaller than the size of variance of zeta. So if we think about variance of epsilon, for example, epsilon follows normal 0, sigma 1 square, and zeta follows normal 0 sigma 2 square, then by comparing this ratio of two variances, you can see which model have smaller variance and how much the variance is smaller. So F statistic, F distribution is used to represent that kind of random variables. And this normalizer M and N just makes the denominator has the expectation 1 and the numerator have expectation 1. So you can see that this is chi-square, this random variable on both numerator and denominator, and each term has expectation of 1. So if we have m terms, then expectation is m because each term is the square of standard normal square. So if we divide by m, then on average, the numerator is 1, and also on average, denominator is 1. So typical value of f is around 1. And the shape of the distribution is most of the time this kind of skewed distribution. And if degrees of freedom 1 is small, often we have this kind of distribution. If df1 and df2 are both large, we have almost this kind of normal distribution, but the slightly heavier tail on the right-hand side. So this is the idea of F distribution and the definition of F distribution. Yeah, and F distribution can be used in R by using the same kind of function. Excuse me, RF function and PF function, QF function, and what the PQR and DF function. For example, if you want to calculate probability of F distribution with DF1 is equal to 2 and DF2 is equal to 5 of is less than, for example, 0.8, then this is calculated by PF 0.8, DF1 equals to 2, and DF2 equals 5. So in R, you can use this code to calculate this. Okay, so now that we finished all distributions, and we're going to review what's the relationship between variables. The F distribution, F random variable is the ratio of two chi-square random variable, and the chi-square is also represented by the standard normal distribution. And there are some good pictures on how statistical distributions are related. And one famous one is in a book, the Caselar and Vargas book, The Statistical Inference. So this is a very classic book and used in many places. And Stat 5800 uses this textbook. Or maybe no, the Stat 5800 is using a slightly easier textbook, but this textbook is used in many statistics department, even in PhD program. And also this article has a little more comprehensive map on how distributions are related. So this is actually the picture of Caselar and Vargas textbook. So you can see the normal 0, 1, normal distribution with mean 0 and the standard deviation 1 is here. And if you add some constant and you multiply this random variable by sigma, you can make the normal distribution of mean with mean mu and the variance sigma square. And another way, if we apply the inverse of this function, then we get the normal 0, 1 again. And chi-square distribution is the sum of the squared standard normal distribution. So chi-square distribution is here. And if you take the ratio of chi-square distribution, that is F distribution. And T distribution, so remember that the T distribution with df nu, if we square it, this becomes F distribution with df1 and nu. So yeah, so this holds. So you can just see the definition. T is the normal divided by square root of chi-square over the degrees of freedom. So if you square it, then the denominator we only have, the numerator we have only 1 the squared standard normal, and the denominator we have n. So if we replace n by nu here, but the t square is basically F distribution. So if we take square, in some sense, T becomes F distribution. And some other famous distributions are here, such as Cauchy or log normal or gamma distribution, beta distribution, uniform exponential, Weibull, and double exponential. So if we see, you see this map, you can see how distributions, random variables are constructed from more basic random variables. Okay, so this is the end of the chapter 3.